after doing number 1, number 2 is a little bit redundant, but let's just go through the motions here. If we're using my mass of 55 kilograms, then my force of gravity using the old equation is mg, which is 55 times 9.8, which is, plugging it in, 539 newtons. Okay, and then doing it the new way, Fg equals G m1 m2 over d squared. So for G, we're going to use 6.67 times 10 to the negative 11. M1 is just 55, my mass. M2, the mass of the Earth, divided by the radius of the Earth squared, which is 6. Sometimes we use 6.4, 6.38 times 10 to the 6. And then we have to square this. I'm going to check this because I have a feeling my number is a little off, but it's good enough for now. So bear with me while I plug this in. Times 55 times 5.98 divided by 6.38 times 10 to the 6 squared, and I get 538.9. 538.9 newtons. Okay, pretty good. So why the discrepancy? Well, the truth is, this number we've been using, 9.8, is itself an approximation. We're kind of making an assumption about the radius of the Earth, or the distance away from the center of the Earth, in each case. But as you know, there's different, the Earth isn't perfect. There's Death Valley, there's Mount Everest, there's different peaks and valleys. So it's possible that you could be a little closer or a little farther away from the Earth at any given instant. And so this equation, the second one, really takes that into account. If you can be much more accurate with your numbers. What's the big difference between these two numbers? Not very different. What we can say is, to two significant figures, G generally rounds to 9.8. So this number is a fairly accurate number as far as we're concerned. So we're not gonna sweat the small variations.